Hi everyone, my name is R. Krishna Kumar. I am working as an assistant professor in the Department of Biomedical Engineering at KPR Institute of Engineering and Technology, Coimbatore. Today we are going to speak about data structures, the basic operations and the basic elements of data structures. In this session, we are going to cover the topics what is data structures, and we are going to understand abstract data types, list abstract data types, and array based implementations. And at the end of this session, you will be understanding what is data structures and types of data structures, and you can explain the operations of list using arrays. Now, what is data structures? Data structure is basically a group of elements that are put together under one name. For example, we have read about arrays, functions, class, these all in the C and C++. When these groups of elements are put together under a single name, single domain, then that comes under the term data structures. But why? When it is comes under one name and which defines a particular way of storing and organizing a data. When the term data structures, you can understand that data is an information with data is a meaningful information, while structure is a structured data. Okay, so when these group of elements are brought together under a single name, and the data which are present inside these elements will be stored and organized in a efficient manner so that it can be used in efficient way. Okay, now data structures are building blocks of a program. So you can see that for a program to build, we have various functions, classes, defines, declarations, syntax, printf, scanf, those things. Similarly, these are all called the building blocks of a program. Similar to which data structures are also building blocks of a program. The data structures, when I say data structure, it has for loops, condition statements, classes, functions, everything. So when these elements comes under a data structure, this data structure, when it is used as a building blocks, we can create a program. Program is not only the coding program, an application. Okay, so then we come to applications of data structures. Data structures are all used in almost every programs or software systems. Some examples of data structures are arrays, linked list, queue, stack, binary trees, and hash tables. Data structures are widely used in the following areas: compiler design, operating system, statistical analysis packages, database management system, numerical analysis, simulations, artificial intelligence, graphics. As we see, AI is an important parameter, or AI plays a major role or key role in our day-to-day activities. Starting from our sending a mail subject, asking a request letter, permission letter, to the Instagram posts or the statistics or the present trade stock analysis, or even the up to journals itself. Without ChatGPT, we are not doing anything. So that ChatGPT is an artificial intelligence, and this data structure plays role in artificial intelligence too. Now data structure is broadly classified into linear data structure and non-linear data structure. We will see the difference in the next slide. This slide I'll just say about what with the term linear and non-linear and their types. Linear data structures, with the name itself you can understand that this type of data structure, linear one, linear in the sense a straight or a single line path or a one way like that, kind of a linear one. And linear in the sense it starts at the beginning and ends at the last, that is linear, a normal pathway. Whereas the non-linear is the end comes first and start comes second, and sometimes middle comes first, then end, then start, that, and the sense the pathway will not start at the beginning at the start and finish at the end. This changes. So under linear and non-linear, again we have subclasses. In linear we have static, and array comes under static, and dynamic. Dynamic, there are three types of data structures are present in under comes under dynamic. One is linked lists, another one is queue, and another one is stack. Static and dynamic, if you get the difference, static is it does not change with the time, while dynamic it changes with time. Okay. And in case of non-linear we have tree, graph, and we have hash also. So the infographic representation of linear and non-linear data structure is presented in this slide. If we see linear data structure, say for example first array. We know array is a set of similar elements present in the single or assigned or grouped under single element. That is array, right? So if those elements, these are in the normal horizontal order, starts from first address element and it goes on. And if you see compare with the tree, the same numbers that will be in the branched order. Or graph, take graph, same 1 3 2 5 4, but that is drawn in the different pattern. And I'll explain that when I say the difference between linear and non-linear, I'll tell the difference between this array and graph representations. And then if we see linked list, the same like linear like array, but these elements 1 3 2 5 4 and all are called as data or elements. Okay, linked list comes with two things. One is this data or elements, the second thing is called a pointer. That pointer is nothing but the address of the second element. We'll discuss about in detail when we come to the linked list topic. Okay, so stack, queue, tree, graph, heap, these things which I have told before, these things will be, and hash, this also I told you, hash table. These things we will discuss on the respective topics. Now linear data structures. Linear data structures, data elements are sequentially connected and each element is transversable through the single run. Transversable is used for the term display here. So in data structures, so data structure elements are sequentially connected, connected with one to one in the orderly manner, and each element is transversable through single run, in the sense either 1 to 10 or 10 to 1, and the run is single run. Either it will go 1 to 10 at the stretch, or it will come from 10 to 1. We cannot start at the middle, and at a time from both sides we cannot run the program. These things comes in the linear data structure. Well, non-linear data structure is a hierarchical connected and are present at various levels. So it doesn't mean that you have to start from the one. It can be middle level start or high level start or lowest level start, and multiple types of start is there. For example, take for example 3D printing as an example. We have two types there: additive printing one thing, another one is subtractive printing, which comes as one is comes from the start base and building, other one is comes from the top and completing at the bottom. Similarly, it can be done in both ways. And linear data structures can be traversed completely in a single run, in the sense in a single while, for example a while loop or for loop, within a single run the elements will be displayed or traversed in a single run. Well, non-linear data structures are not easy to traverse and need multiple runs to be traversed completely. For example, in the previous example, arrays 5 elements were there, and in the graph the 5 elements were interconnected to one another. So if you want to print in, you can print those elements in different orders, and if you want to analyze those patterns also, it will go to different number of runs. For example, 1 3 2 5 4 is an option, and in the previous slide if you see 1 3 2 4 and 5 can be done. So like that different type of run is possible, and multiple runs are necessary actually. And linear data structures are not very memory friendly, and memory cannot be utilized efficiently. This can be explained with the help of array and graph, which I represented before. If we see array, 13254 number was there, right? So if I want to find 5, then I have to run either from first element, that is 1, or from the last element 4. Whereas in non-linear, which is in graph, similarly 1 3 2 5 4, if I want to find 5, I can find directly 5. And also if I want to run this print all the elements, then I have to print from the first element. So first element will be printed, second element, then third, fourth, and followed by last element, and which is 4. Whereas in graph, if you see 1 3 2 5 4 is interlinked, so to go to 4 I need not run all the elements. I can run 1 5 1 2 and directly 4. As some sample graph was there, right? In the previous slide you can check that. Okay, that is why, so memory can be stored. Two memories can need not be used in the graph. So that is why nonlinear data structure uses memory very efficiently. And time complexity of linear data structure often increases with increase in time, increase in size of the elements. For example, in an array or linked list, the size of that the variable. Whereas in nonlinear, time complexity remains same even with the increase in size. And examples are array, list, queue, and stack. Here graph, map, tree, as I said, heap, hash, everything. So with this we'll conclude the first topic, the difference between linear and nonlinear data structure, broad classification. In the next class we'll see about ADT and the operations of list using arrays. Thank you.